Hello everyone. In this video, we'll be solving problem 345, reverse vowels in a string. The problem statement is, given a string S, reverse only all the vowels in the string and return it. Vowels, that is A, E, I, O and U, they can appear in both lower and upper cases more than once. So looking at example number 1, these are the vowels. If we start reversing them, our output should look something like this. This A should be moved to the front and replace I and vice versa. So it will be A uppercase C. This E should be replaced by the other E over here. So it will stay the same. C R. This E has been replaced but with the E itself. This A is replaced by I. Then M stays as is, which is our output. Now let's jump into understanding of potential solutions. To solving this problem, there are multiple approaches. We'll start with the basic naive approach and then we'll think about how it can be optimized. The naive approach would be to iterate through all the elements in the given string, identify all vowels and its corresponding indices, save it somewhere, and using the saved vowels and indices, we'll recreate the string. So let's start one small iteration. So my I pointer is pointing at 0. Is it a vowel? Yes. So I will save it in a separate array. I'll save only the index, which is 0. Following that, I am looking at C, which is not. So I will continue to increment my I. So now it is 1. 1 is pointing to C. C is not a vowel. Next is 2. 2 is pointing to E, which is a vowel. So I will record its corresponding index here. Moving on, 3 and so on and so forth. So I figured out all the indices. It is 0, 2, 5 and 6. Now I will recreate my string. And whenever I am at particular index like 0, I will replace its corresponding value with 6 and vice versa. So with this approach, our time complexity is O of n, as we are iterating through the string, and our space complexity is also O of n, as we are maintaining this array of indices. This is a workable approach, but let's talk about how we can optimize it further. Another way to solve this problem is using two-pointer approach, where we will have 2 pointers, one pointing at the start and other pointing at the end. Pointer number I, which starts from the beginning, will be incremented while j will be decremented. So in our approach, we'll start by using the I pointer and check if the character at the pointer I, if it is a vowel or not. If it is a vowel, then we will start checking the character at j pointer. If j is also pointing to a character which is a vowel, we know both I and j are pointing to vowels, and then we'll replace it. If j is not pointing to a vowel, we will decrement the j pointer until we know it is pointing to a vowel. We will continue to do that until I is less than j. Once this condition is breached, we know that we are at the center of the string and there is no point in continuing further. So we'll just exit out of the loop and return the reversed string. Let's run a couple of iterations using this example. Let's use this table to track the iterations, starting with I is equal to 0 and j is equal to 7. Now I is equal to 0, so character is going to be I, which is a vowel. So we'll now look at j. J is pointing at 7, which is M. Is this a vowel? No. So we'll decrement j, which will become 6. C of I is still the same. Now C of j is A, which is a vowel. So I will have to replace it. And this replaced character will be saved in an result variable. Now that we have reversed a character, we can increment our I and decrement j at the same time. So I will be 1, j will be 5. Now what is I pointing at? C. My j is pointing at E. E is a string, so I will leave it as is until we find the replacement. Increment my I, so I will become 2. This is 5. What is my I pointing at? It is pointing at E. and my J is still pointing at E, which is a vowel. So we'll do the replacement. Now let's resume the same logic that we did earlier. Increment I to 3, decrement J to 4. I is pointing at C, capital C, and my J is pointing at R. Both are not vowels, so we can increment and decrement at the same time. So 3 will become 4, J will become 3. Our original condition is breached. I is no longer less than J. So we will exit out of the while loop, rebuild the string based on the results and return it. Complexity will be O of n log n, where n is the number of characters in the input string and the space complexity is O of 1. We can use the input string to maintain and save the reversed characters instead of using the result variable. I hope you were able to understand this solution. Let me show you how we can build this using C#. So here is the solution in C#. I start by initializing two pointers I and j with default values, and then I have a characters array which consists of all of the characters from the input string. I am maintaining a hash set or a map with all the vowels in it, which I'll use for doing the lookup to check if the corresponding character is a vowel or not. I then start with a while loop, and condition is to make sure that I is always less than j. I start by checking the character at I. If it is a vowel, then I check the character at j. If both are vowels, I'm replacing it in the characters array and incrementing the I pointer and decrementing the j pointer. If the character pointed by j is not a vowel, then I'm just decrementing j. And if the character pointing by I is not a vowel, I'm incrementing the I pointer. At the end, I will have the reversed string in this character array, which is what I'm converting into a string and returning it at the end. I hope you were able to understand this solution. The link to this source code is available in the description below. Feel free to check that out, and I will see you in the next one. Thank you.